Hello everybody, my name is Andreas Koop. I work for Siemens Energy as a technical consultant in the area of industrial steam turbine service. I would like to present you at the Lubrication and Reliability Summit 2020 our service for proactive reliability improvement and reactive troubleshooting 24/7. My presentation consists of first a very short overview about Siemens Energy, second a proactive reliability improvement part, third the reactive troubleshooting part, fourth again a very brief summary. Siemens Energy is a worldwide operating company with more than 90,000 employees, and we supply societies around the globe with sustainable, reliable and affordable energy. Basically, we serve the whole value chain from generation, transmission and distribution of energy. Broken it down to the industrial steam turbine service, you find here our portfolio, different types from 1 megawatt up to roughly 250 megawatts. The equivalent of it you will also find in our generator portfolio, and here also listed the large generators for the utility power plants. Our service portfolio is about digital services, performance enhancements, long-term partnerships, maintenance solution, and last but not least, the training and consulting. That's it with a very brief overview of Siemens Energy. Now I would like to start this section here, the reliability improvement, with a short video to give you the first impression about our remote diagnostic service which we offer and which we are talking later on.
We at Siemens understand that reliable operations are key to a profitable and sustainable business. Remote diagnostic services allow us to support our customers 24 hours a day in a 7-day week, increasing their availability and reliability. The remote diagnostic service is an integral part of the Siemens high-value long-term programs. In over 80 countries, we monitor the complete range of oil and gas and industrial rotating equipment. In our remote diagnostic centers, embedded in the dedicated locations of our product lines, we process the data of more than 1,200 units for oil and gas industry, power generation and industrial clients. We serve complete trains consisting of gas turbines, both industrial and aeroderivative, steam turbines and compressors, covering generator set and mechanical drive applications. Per year, we process over 1.2 million automated tasks and 1.5 million data files. Advanced pattern recognition and the deviation of normal behavior techniques support the fault detection at an early stage. Unplanned outages can be shifted into planned maintenance activities, and trips can be avoided.
So I hope you liked that short video. Our remote diagnostic service consists mainly of three important parts. It's the 24/7 remote support. These are operational recommendations and case something goes wrong or value shows some deviations. And the most important thing are the predictive analytics. Predictive analytics, what does that mean? That the different measurements which every operator can see, they are combined into a model or describing the whole behavior, for example, of a turbine, a part of a turbine, of a condenser, of the valves. So that means the predictive analytics is quite a nice algorithm, or many algorithms, which shows and which describes operational behavior much better than anyone could judge by just checking single data trends, for example. And that is the most important part to see, to realize for us. Deviations from the expected values at a very early stage, from the beginning on, and that's give us a chance to react soon and faster enough than any operator could do it for many operational disturbances. You can see just an overview about our remote diagnostic centers, the tasks they do, where they located worldwide, and which sort of industries we serve. The RDS tackles mainly the questions of reliability and availability, tries to increase, to improve both of them with different tools, different processes. We both together enables us to improve your operation and your whole plant management in sort of the before mentioned reliability and availability aspects. This is especially the higher availability through fast problem analysis, the higher reliability through the predictive analytics, the turbine-specific outage planning, because we know very well about the behavior of that turbine, the areas to address during an overhaul, and of course some operational recommendations in case we found some deviations. I will give you an example. We have at the left side of the slide the customer's control room with a process value well above the alarm and warning level. And at the right side you will see our remote diagnostic center with our virtual colleague John. He realized some deviations with the predictive analytics well before the operational side, the customer side, is able to realize that. The deviation is listed in a monitoring tool, and that gives an alarm to John. And this alarm is of course not the customer's alarm. It's an alarm brought with stricter level of this operational deviations which is triggered here. Of course, first he has to check if it is a true deviation. In this case, we expect it as a true deviation, and John has identified it in this way. He will start a risk assessment and the fault isolation process. Risk assessment is about the impact and probability as well to the operational side as environmental issues. That's all of this is taken into account. When he did it, and that's a severe risk, he will directly start the isolation process of the fault and try to get to proper diagnosis. And with help of the system, with cases from the past, that shows the probability of diagnosis made by John. In case of any doubts, and in case he needs additional support, John always contacts the back office specialists and the help desk team. And when the fault isolation process is done and the recommendations could be given via notification to the customer directly afterwards and in a very short time interval. This is how this notification looks like. It explains the deviations, the technical findings, short and midterm recommendations, and it's always given and provided within 12 hours between the finding was made and the customer was contacted. I would like to give you 2 examples about this fault isolation process and the deviations recognized by the predictive analytics. The first one is an industrial power plant with heavy fouling, heavy deposits in the blade area. The so-called inlet section of steam pass index showed that deviation because it increased. This behavior was recognized and led to the conclusion of the fouling. In this case, a cross-check was done with periodic boroscopic inspection, which also revealed the inlet section of steam pass index was totally right. The blades were full of heavy deposits. Recommendation was provided for a washing process and to improve the steam quality to avoid that in future. The benefits of the customer are quite clear. The insufficient operating condition was detected at an early stage, and the root cause with the subsequent recommendations were given. Second example was the early detection of a condenser fouling at a pulp and paper industry. In this case, a different index, the so-called stage pressure index, LP, showed that deviation. The conclusion was that there's a problem in the condenser fouling in the condenser, especially in the condenser tubes. The customer was consulted and they confirmed that they have problems with cleaning balls. Together with the customer, we redesigned the condenser to avoid the dead spots where the cleaning balls get accumulated. And after the cleaning balls went into operation, a successful operation again, the stage pressure index showed the low and values like before. Again, an insufficient operation condition could be detected at an early stage, and together, in combination with the customer, we were able to solve the problems and to give proper recommendations. So, coming to the part 3 of my presentation, reactive troubleshooting 24/7. In this case, it is most important, I named it here, what if an unplanned issue or shutdown really happens. It is most important to be able to react very, very fast, especially in times like nowadays with travel restrictions. It shows that it is quite often very time consuming to send someone to the customer side to deal with really a major issue. For this we set up a remote support process. We call it internally virtual guidance. That's quite a strict forward remote support. Everything what is needed at customer side is basically a smartphone, a good network connection, and finally a QR code from our side, which is sent, for example, by email. And with help of the QR code, a direct connection is established between the back office in Germany, in this case, and the customer side worldwide, with instant direct support. I will show you some pictures. There you see the smartphone at the customer side, and the operator there is able to mark something, to write down something, of course to video stream the defective area or to take pictures of it. Here down at the right you will see our back office expert seeing the same thing what the customer at the customer side sees in the same time, and is in direct connection and direct action with the customer to guide and to receive the essential information directly from customer side. That's basically it for our proactive and reactive support, which improves the availability and reliability in our industrial steam turbine section of Siemens Energy. Hope you liked it. If you have any questions, do not hesitate to contact me. And thanks for watching. Goodbye.